Hello dear friends, welcome back to my YouTube channel. Now in today's lecture, we are going to learn about the factors affecting or influencing the SN1 and the SN2 reaction mechanism. So in the previous two lecture, we have learned about details of your SN1 and the SN2 reaction mechanism one. There are the three important factors that affect the SN1 and the SN2 reaction mechanism. Out of that, the first factor is the nature of substrate. Now, which particular type of the alkyl group you are going to take, it will affect the SN1 and the SN2 reaction mechanism. Second one is the nucleophilicity of the reagent, that means the nature of your nucleophile, that is. Then next one is the solvent polarity. Now, which particular solvent that you are using for your SN1 and the SN2 reaction mechanism one. Now, the nature of that solvent also affect the SN1 and the SN2 reaction mechanism. So out of that we will start the third factor, that is solvent polarity. So here again we are going to consider the solvent polarity for your SN2 reaction mechanism and for the SN1 reaction mechanism one. So remember, for SN2 reaction mechanism, the polar protic solvent decreases the rate of SN2 reaction mechanism one. Now you know that in the rate determining step, the substrate and the nucleophiles are involved one. This polar solvent stabilize the nucleophile by the solvation effect, and thus the solvent deactivates the nucleophile one. Now what is exactly the polar protic solvent one? Now listen, generally in the polar protic solvent, the hydrogen atom is attached to the more electronegative element one. Okay, if it is attached to the more electronegative element, then it will give the dielectric property, that is del plus, del minus. Okay, or simply it is called as a polarity. So these particular solvents are polar in nature. For example, if I consider the H2O molecule, okay, you know that this oxygen will have a more electronegativity, that's why it will have the del minus charge. Now this each hydrogen atom will have the del plus charge one. You know that in the SN2 reaction mechanism, the nucleophile OH minus, okay, as it is having the minus charge, so these positive del plus positive hydrogen atoms can trap this OH minus ion to different H del plus hydrogen ion will form the hydrogen bonding with this solvent one, del minus, del plus. Okay, so this OH minus ion can be trapped by this particular solvent molecules one, which is actually your polar solvent molecule or the polar protic solvent molecule one. Now if they are trapped, this nucleophile is trapped by this solvent molecule, that is nothing but your solvation effect. Okay, so remember, if it is trapped, then obviously it will get stabilized and it will not attack on your substrate, and hence this SN2 reaction mechanism will not be favored. So therefore just remember one important thing, polar aprotic solvent will favor the SN2 reaction mechanism. Now what is polar aprotic solvent? Now remember, this polar aprotic solvent, for example acetone, dimethyl formamide, then dimethyl sulfoxide. If we take the example of your acetone, CH3 C double bond O CH3. Okay, now remember here this each hydrogen atom of your methyl group is not directly attached to your more electronegative element one. That is the important factor. That's why they are called as an aprotic solvent one. Remember, okay, and remember they are not capable of forming the hydrogen bonding here one. We know that this oxygen is a more electronegative than carbon atom, therefore it will have the del minus charge, while this carbon will have the del plus charge. Now again remember, this hydrogen atom will not have any del plus charge, so that's why these particular solvents are called as a polar aprotic solvent. If they do not have the positive charge. Again remember, so obviously the SN2 reaction mechanism will be favored in the polar aprotic solvent only. Okay, they will not trap your OH minus ion. Consider the SN1 reaction mechanism. Remember, SN1 reaction mechanism is proceed via carbocation intermediate one. A good ionizing solvent, that is a polar solvent, stabilize the ions by solvation. Okay, now this solvation of carbocation is relatively poor, and the solvation of anion, we are using the two different words, carbocation and anions. You know that if we consider the SN1 reaction mechanism, there is formation of your carbocation, that is tertiary butyl carbocation, plus we know that there is a release of Br minus anion. Okay, so this Br minus ion cannot further react with this your carbocation because of this solvation effect one. Remember, this is the important thing that I am telling you. This is nothing but your anion. That anion undergoes the solvation effect, so that's why I have written it as an solvation of anion is particularly important here. Okay, these anions are solvated by your hydrogen bonding by your polar protic solvent one. That means what? This Br minus ion can be trapped by your polar protic solvent molecules one. So this Br minus can form a weak hydrogen bonding with the hydrogen atom of your water molecule or the water which is a polar solvent one. So that's why this is the important factor that I am going to consider here. This effect is called as a solvation effect. That means what? This Br minus ion is trapped by these different water molecules, and it will not further react with your carbocation, and hence the further SN1 reaction can proceed more rapidly with in presence of your polar protic solvent one. So this is a simple solvent polarity one. Just keep this thing in you. The solvation effect plays an important role. Now if we have to summarize this one, you know that SN2 reaction mechanism is favored in presence of polar aprotic solvent, while the SN1 reaction mechanism is favored in presence of polar protic solvent. Okay, so you know the difference between the polar protic solvent and the polar aprotic solvent. So your polar protic solvent is capable of your hydrogen bonding. Okay, this is one intermolecular force of attraction. Okay, while they are not capable of hydrogen bonding one. So that's it. So these are the examples of your polar protic solvent and the apolar protic solvent. So you have to keep this point in your mind, that is SN2 reaction mechanism is favored in the polar protic solvent, while the SN1 reaction mechanism is proceed via polar protic solvent one. Thanks for watching this video. See you in my next video.